So this is tester 1. I'm going to create a clone of this machine and make it tester 2 machine. This machine will become tester 2 for me. Once the clone is done, I will have 3 machines. Server 1, I'm in the server, tester 1 and tester 2. In the meanwhile, since my server machine is already running, let's initialize the cluster. The command is quite straightforward. To initialize the cluster, docker swarm. This is how you specify, this is how you initialize the cluster. The command is docker swarm init and advertise IP. This advertise IP address is mandatory because in our case, the default IP address, the first IP address of the machine is 10.0.2.15. And check that, I'm talking about non-localhost IP address. Let me show you. So IP space A, if you don't specify that advertise IP address, the first IP address, which is this IP address 10.0.2.15, will be advertised. Advertise means that the other node will be able to join using this IP address. Now, since this is NAT-based IP address, other machines cannot reach using this IP address. In other words, the NAT-based IP address is for one-way traffic. From the machine, from the instance, you can connect to the internet or outside world, but outside world cannot reach you. So this NAT-based IP address will not be sufficient for us. That is the reason we have to use the second IP address, which is reachable from tester 1 and tester 2 also. So we need to use this IP, and that is the reason I have specified advertise address. And this is the IP address. So this will initialize the cluster. So cluster is initialized. Now this is the command which we need to execute on tester 1 to ensure that it join the cluster. But of course we need to install Docker on tester 1 as well. So let's do one thing. Let's check the repository, configure the repository on tester 1 and tester 2. And then after Docker is installed on tester 1 and tester 2 machine, then we will execute this command. Okay. So just give me 2 minutes. In the meanwhile, let my machine comes up. After the clone is complete, you need to keep tester 1 machine off and start tester 2 machine, that is clone machine. And go to the machine tester 2, log in as root user, and you need to make only 2 changes. One is the IP address etc sysconfig network scripts ifcfg-enp0s8. This is the second interface, second network interface card. We need to change the IP address in the second interface only, and we need to make the IP address 102. This is change number 1. We change the IP address. Second change is the host name, which is under etc host name. Into this file, here you see the host name as tester 1. You have to make it tester 2. With these 2 changes, you reboot the machine with the reboot command, and then you can start your tester 1 also. So now I'm ready to start tester 1, and tester 2 IP address is changed, tester 2 host name is changed, and therefore my tester 1 and tester 2 both the machines are ready. And hence I can simply go back to my server machine and connect to my tester machine, that is tester 1 or tester 2 both machines, and I can execute the join command. Let's execute the join command. Once that, let me try first ping tester 1, because I wait for machine to come up, and the moment machine comes up, I will see the ping command reply. So let's wait. Yes, destination host unreachable, and I'm sure I'll get the reply within a few seconds now. Yeah, I'm getting the reply now. So my tester 1 machine is ready. Now I can execute the join command, which was available here on this machine. But before that, you very well know we need to install Docker on this machine. So let me copy the command history. I can use grep and the command was dnf, and I'll see the repository here, config manager docker repo. I need to execute this command on my tester1 machine. So ssh tester1 and execute this machine, this command to install docker. The same command we configure the repository first. Now it is revision because we have done the installation of docker earlier, and install docker now. Dnf install docker-ce. So this will install docker ce, that is docker container engine, on tester1. Same thing we need to do on tester2 also. So let me go back to tester2, ssh tester2. Surprisingly, I don't have to copy the ssh key pair on tester2 because tester2 is nothing but clone. So I'll get a warning and then it will allow me to log in without password. And you see the warning, and after that I'll get login directly. So I'm logged into tester2 also. This is tester2. This was tester1. So let me configure the repository on tester2 also. So we'll have a 3-node swarm cluster up. So configure this repository on tester2 machine also, and then execute the command to install docker ce. So dnf install docker ce on tester2 as well. So this will install docker ce on tester2 also. Tester1 installation is going on. Server machine is up and running. So after my docker is installed on both these machines, I will simply have to execute this command on tester1 and tester2 both. So should not take much time now. So I do this parallel work, and I encourage you to do parallel work like from one terminal window using ssh command. Ssh keygen first to generate the key, ssh-copy-id to copy the ssh key, public key to the .ssh folder on the remote machine, and then enjoy connectivity without password. And this is the preferred mechanism to work remotely. So this installation is almost complete on tester1 and on tester2 also. After that, what I will do is I will start the service and enable it so that it starts after reboot. And the command is systemctl enable --now docker. Systemctl enable --now docker. This will start docker and it will enable it so that it is restarted after the system is rebooted. We need to execute the same command on tester2 also. So this will create a cluster where docker is running on all the 3 machines, and the swarm will create that cluster. Now I'm enabling and starting the docker on this machine as well. Now I'm good to execute this join command, and I can use this to execute on this machine tester1, and same command I need to execute on tester2. So this will join the cluster, and I'll get a confirmation that this node have joined the cluster. Enable description, transport error while dialing this. Okay, this port is not open, so we need to open this port 2377. That means firewall is missing. Systemctl, sorry, firewall D. Don't run away from these errors. CMD 2377/TCP and reload it. So now let's try to execute the same command and see how quick it is. This nodes have joined the cluster. Same command I need to execute on this again and join the cluster. So that means I have a 3-node cluster. Now let's create a service. Let's deploy Nginx server on the cluster. So for that, I'm going to use this command docker service create in detached mode. 4 replicas should be running, and the name OCI test service, mount source OCI test, target slash app, and the image name is nginx latest. So it is created. To verify whether the service is running or not, we can use Docker service ps OCI test service, the name of the service what you created and running, and see where this service is running. 4 replicas, that is the availability, that is the high availability I was talking about. So tester 1 it is running desired state, right now it is preparing on tester 1 also. So another replica, one replica is running on tester 2, two replicas are running on tester 1, and one will be running on server. So 4 replicas will be running. So let's see, and see it is running on all. Earlier it was preparing, now it is running. So we have one replica on tester 2, one on server, and two on tester 1. So we have 4 replicas of this container running now. That is the Swarm cluster. Let's start the lecture now. Session 6, Introduction to Docker Swarm. Remember, there are drawbacks, there are downsides of Docker Swarm, and if you want to learn more about it, stay tuned, because this training we will discuss the detail and the difference between Docker Swarm and Kubernetes. Why do we use Kubernetes when we can use the same thing with Docker Swarm? There are reasons for that, and there are genuine reasons, good reasons that we don't use Docker Swarm, but there are some specific use cases, there are some scenarios where Docker Swarm is good enough. So that we will discuss in the Kubernetes topic. But right now, let's understand how Docker Swarm works. So Swarm working model, configuring a Swarm cluster or Swarm manager, configuring Swarm nodes, and creating services and stacks. You have seen the demo of the entire thing. So, and the lab assignment is also there for the same purpose. You'll be creating a Swarm cluster. You'll be creating volumes also. You'll be attaching volume from one node to another. I mean, you will be storing, creating volume and attaching it to the running container. That's what you will do in the lab assignment. So lab is quite comprehensive, which we will do after this lecture is over. A Swarm consists of multiple Docker hosts which run in Swarm mode and act as managers and workers. A given Docker host can be a manager, can be a worker, or it can perform both roles, that is manager as well as worker. When you create a service, you define number of replicas. Recollect the examples, we created 4 replicas. Network and storage resources available to it, we did not specify that, we could have specified. Port the service exposes to the outside world, and more. Docker works to maintain the desired state. If you notice that in the output of last command, there were two columns. One was desired state and one was current state. Desired state is what you are expected to do. Current state is what the current status is. For instance, if a worker node becomes unavailable, the Docker schedules that node's task on other nodes. The task is a running container which is a part of the Swarm service and managed by Swarm manager as opposed to a standalone container. What are the advantages of Docker Swarm? You can modify a service configuration, including the network and volume it is connected to, without the need to manually restart the service. Docker will update the configuration, stop the service tasks with the out of date configuration, and create new ones matching the desired configuration. When the Docker is running in Swarm mode, you can still run standalone containers on any of the Docker hosts participating in the Swarm as well as the Swarm service itself. That means Docker Swarm is not taking complete control of your Docker daemon. You can still run independent or individual containers using Docker, not participating in Swarm without going through the Swarm. Standalone containers versus Swarm containers or Swarm service. Only Swarm managers can manage a swarm, while standalone containers can be started on any daemon. Docker daemon can participate in a swarm as manager or worker or both, as we discussed earlier. The node is an instance of the Docker engine participating in the swarm. So in our case, there were three nodes: server, tester 1 and tester 2. You can think of this as a Docker node. You can run one or more nodes on a single physical computer or cloud server, but production swarm deployment typically include Docker node distributed across multiple physical and cloud machines. The manager where I executed the command docker swarm init. To deploy your application to swarm, you submit a service definition to manager node. That means that the service which I created, I executed that command on server, not on tester 1 and tester 2, because server is the master in my case. So the manager node or the master node dispatches unit of work called tasks to worker nodes. So I submitted the task to my manager, which was server, and that task was distributed to tester 1 and tester 2. Perform the orchestration and cluster management functions required to maintain the desired state of the swarm. Also, elect a single leader to conduct the orchestration tasks. The worker nodes are additional nodes. Worker nodes receive and execute tasks dispatched from manager nodes. By default, manager nodes also run services as worker nodes, but you can configure them to run manager tasks exclusively and be manager only node. That means you can define a specific machine as manager only. The agent run on each worker node and reports on the task assigned to it. The worker node notifies the manager node of the current state of its assigned task so that the manager can maintain the desired state of each worker. Services and tasks. A service is the definition of the task to execute on manager or worker nodes. It is the central structure of the swarm system and primary root of user interaction with the swarm. When you create a service, you specify which container image to use. As you remember, in my case, I use Nginx image, and which command to execute inside running container. In the replicated service model, the swarm manager distributes the specific number of replica tasks among nodes based on the scale you set in the desired state. For global service, the swarm run on one task for the service on every available node in the cluster. A task carries a Docker container and the commands to run inside the container. It is atomic scheduling unit of swarm. The manager nodes assign tasks to worker nodes according to the number of replicas set in service scale. Once the task is assigned to a node, it cannot be moved. That's the drawback. That's a very important drawback which is possible in Kubernetes. In Kubernetes, you can move the pod from one host to another. But here it says it's not possible. It can only run on the assigned node or it can fail. Load balancing. The Swarm Manager uses ingress load balancing to expose the services you want to make available externally to the Swarm. The Swarm Manager can automatically assign the service a public or published port, or you can configure a published port for the service. You can specify any unused port for the service to be available. If you do not specify a port, then Swarm Manager will assign a service a port from this range 30,000 to 32,767, this range. All nodes in the Swarm route ingress connections to a running task instance. The Swarm mode has internal DNS component that automatically assign each service in the Swarm DNS entry. The Swarm Manager uses internal load balancing to distribute requests among services within the cluster based on the DNS name of the service. Now, configuring a swarm manager, which you have seen the demonstration, that was theoretical background needed. You need SwarmKit, that is cluster management and orchestration feature embedded in Docker engine. So you don't need anything, that are built using SwarmKit. You need the following: 3 Linux hosts which can communicate over a network with the IP address of the manager machine and open port between the hosts. One of these machines is a manager called server, and two of them are worker, in our case tester 1 and tester 2. Then we open the firewall. These are the firewall ports which need to be open: 2377 and 7946, and this is UDP port 4789 and 7946. These are TCP port, these are UDP ports. Once you open these firewalls, this 2377, this port is required for cluster management communications. This TCP and UDP 7946 is communication among nodes, and 74789 is for overlay network traffic. Overlay network traffic means the containers working and talking to each other. And this is the command which I executed: docker swarm init advertise address, and this is the same address I used, and I got this output. Also I got this command to be executed on the worker nodes. This advertise address flag configure the manager node to publish its address as 10.10.0.100, and if you don't specify this, it will use the first non-localhost IP address, which is 10.0.2.15, so which will not be possible to reach, which is not reachable from other nodes. The other node in the swarm must be able to access the manager at the IP address. That's the reason we specify this specific IP address. The output includes the command to join new nodes to the cluster to the swarm. So Docker info will give you the information about the cluster, that is node address and manager and the address. And if you use Docker node ls, that will give you the nodes participating in the cluster. Then configuring swarm nodes, tester 1 and tester 2. You simply execute the command docker swarm join with the command, and you will get the message. If you lose that command, if you don't have the join command, you can retrieve the command using this docker swarm join token worker. That will give you the command if you miss that command. And execute the same command on tester 2 as well, docker swarm join. This is the output screenshot, since I have demonstrated, so I'm sure you'll finding it easy. When you use docker node ls, that will give you all the nodes, and the star indicate that this is the master node or manager node, and which is written here also in manager status, this is leader. Understanding the output, the manager column identify the manager node in the swarm. The empty status in this column for tester 1 tester 2 identify them as worker nodes. The swarm management command like docker node list or docker node ls only work on the manager node. You cannot execute this docker node ls on worker nodes. Creating services and stacks, that's what we discussed and I demonstrated. Open a terminal on your manager node and run this command: service create one replica, name is hello world, image is alpine, and execute this command ping docker.com. In the command docker service create command, docker service create, this command create the service. Hyphen hyphen name, the service name is given. Replicas, we need one copy. Arguments alpine ping docker.com, this define the service as an alpine Linux container that will execute the command ping docker.com from that, and that's the precise command I executed. Docker service ls, that will see the list of services running, and as I repeat, inspect command, docker service inspect, and then service name. You can inspect the service in detail. Docker service inspect, that's what I was talking about just now. So docker service inspect, this is troubleshooting. Troubleshooting is no magic wand team. You need to check the logs. I demonstrated one troubleshooting example also where my worker could not join the master or the manager, and you know the reason was firewall. So similarly, if you are getting some issues in the service, you have to investigate the output from this command docker service inspect with hyphen pretty followed by service ID to display the details about the service in an easily readable format like this. So this service inspect pretty hello world, and you see the name, replicas, update config, parallelism, on failure pause, monitoring. So you will see everything, the image, the arguments, initialized, resources. So everything you will see about the service. Verify the service, docker service ps command. That's what we demonstrated. I demonstrated this as well. In my case, I use a different service. In this case, the one instance of the hello world service is running on server. You may see service running on tester one also, because the manager decide where to place the service. SOM also shows you the desired state and current state, two columns. I told you mandatory two columns, and you recollect the output from my demonstration. You can run docker ps command on nodes where the task is running to see the details about the container for the task. Run docker swarm remove rm and the service name to remove the hello world service. So docker service remove service name. Now again you can run docker service inspect service ID, and you will not see any output here. You will get blank. See here, first I removed it and then I inspected it and I got a blank here, and you see no such service found. Even though the service no longer exists, the task contains describes apps using stack files. The swarm never create individual containers like what we did. Instead, all swarm workloads are scheduled as service, which are scalable groups of containers with added networking features maintained automatically by swarm. Furthermore, all swarm objects can be and should be described in manifest file called stack files. These YML files describe all the components and configurations of your swarm application and can be used to easily create and destroy your application in any swarm environment. This is a very simple example of a simple stack file like bb stack. Any example, you can take any example, version, service, and the image bulletin board. You already have that image, and the port mapping. So this is a manifest file. In this YML file, we have just one object, a service, describing a scalable group of identical containers. In this case, we get just one container, the default. That container will be based on your bulletin board image. In addition, we have asked Swarm to forward all traffic arriving at port number 8000 on our development machine to port number 8080 inside our bulletin board container. Deploy your application to Swarm. So docker stack deploy -c create, and the file name is bbstack.yml and the name of the stack. If all goes well, Docker will report creating your all stack objects. Notice that in addition to your service, Swarm also create Docker network by default to isolate the containers deployed as a part of your stack. And you can check that with Docker service ls. Open the browser, visit your bulletin board. You should see your bulletin board example as when we run it as standalone container. Once satisfied, you tear down Docker stack remove demo.